That light, effortless steering wheel in your modern car feels great when you're squeezing into a tight parking spot. But here's something almost nobody tells you about it. It severed your physical connection to the road, and in a lot of cases, it turned a single failed sensor into a repair bill worth thousands of dollars. By the end of this video, you'll understand exactly why that happened, how the two systems actually work under the hood, and what warning signs to watch for before they cost you real money. For over half a century, hydraulic power steering was the standard in almost every car on the road. It didn't rely on computers or software. It used a belt-driven pump, pressurized fluid, and a rack and pinion assembly to amplify whatever input you gave it through the wheel. The idea was simple, and the execution was almost entirely mechanical. Here's the part that actually matters if you want to understand why old cars feel so different to drive. Inside the steering rack sits a small piece of precision spring steel called a torsion bar. When you turn the wheel, your front tires resist that motion because of friction against the road surface. That resistance causes the torsion bar to twist by a tiny, precise amount. That twist opens internal fluid ports, which route pressurized hydraulic fluid into a cylinder that pushes a piston and helps you turn. The harder you turn, the more the bar twists and the more assistance you get. It's a beautifully simple feedback loop. Now here's the detail that made hydraulic steering feel so alive in your hands. Because that hydraulic fluid forms a nearly incompressible column connecting the rack, the valve, and the steering wheel, forces didn't just travel forward from your hands to the tires. They also traveled backward from the tires to your hands. When a front tire hit a patch of gravel, crossed a painted line, or started losing grip in a fast corner, the change in resistance at the tire immediately changed the pressure in that fluid column. Drivers felt that as a subtle shift in steering weight. It wasn't dramatic, and it wasn't some kind of sixth sense. It was real, physical feedback, and most people who learned to drive on these systems picked up on it without even realizing they were reading it. To be honest, this kind of feedback is subtle enough that if you've only ever driven a modern car, you might not notice what's missing until you get behind the wheel of an older one and drive them back to back. That comparison is genuinely worth doing if you want to understand what this whole video is about. So if hydraulic steering worked this well, why did the entire industry abandon it? The answer isn't some conspiracy or corner-cutting move. It comes down to one real engineering weakness. A hydraulic pump is driven directly off the engine's accessory belt, which means it has to keep pumping fluid the entire time the engine is running, even if you're driving in a straight line on the highway and using zero steering input. That constant mechanical load costs a few horsepower. On its own, that might not sound like much, but multiply that loss across an automaker's entire lineup, combine it with increasingly strict fuel economy regulations, and you get real pressure to eliminate that parasitic drag anywhere it's possible. That pressure is what gave us electric power steering, usually shortened to EPS. Unlike a hydraulic pump, an electric motor draws essentially zero power when you're driving straight and only kicks in when the wheel is actually being turned. From a pure efficiency standpoint, it's a legitimate improvement, not a scam or a cost-cutting gimmick dressed up as innovation. But like most engineering trade-offs, you don't get that benefit for free. Let's talk about what you actually give up. Instead of a hydraulic fluid column doing the work, an EPS system uses an electronic torque sensor mounted on the steering column to measure how hard you're turning. That sensor sends a signal to an electronic control unit, which processes it and tells an electric motor how much assistance to provide to the rack. In cheaper, column-assisted setups, which are common in economy cars, that motor sits inside the cabin, right under the dashboard, and drives a small gear against the steering shaft itself. That adds real mechanical friction and rotational inertia directly into the path between your hands and the road. A lot of the fine detail that used to travel backward through hydraulic fluid gets absorbed by that friction before it ever reaches your hands. In more expensive, rack-mounted EPS systems, where the electric motor works directly on the steering rack instead of the column. The physical connection is more direct and generally better. But even there, manufacturers apply something called software damping. These are digital filters built into the control software that intentionally smooth out sudden vibrations and microcorrections, so the steering doesn't feel twitchy or nervous on rough pavement. The trade-off is that a lot of the texture and feedback that used to reach your hands gets filtered out along with the noise the engineers were trying to remove. Have you ever driven a modern car and felt like the steering was almost too smooth, almost disconnected, like something out of a video game? If so, that's not your imagination and it's not a flaw. That's the software doing exactly what it was designed to do. Now let's get into the part that actually affects your wallet, because this is where things get serious for regular car owners, not just driving enthusiasts who miss the old road feel. Hydraulic systems tend to fail in cheap, predictable, and mechanically simple ways. A slow leak from a worn rubber hose, a failed pump seal, or a torn rack boot are the most common issues. A shop replaces the failed part, bleeds the fluid through the system, and you're usually back on the road for a few $100s. Electric power steering racks are a different story. In most modern designs, the mechanical rack and pinion, the electric motor, the torque sensors, and the control electronics are all built and sealed together as one integrated unit. If a single component inside that housing fails, something as small as a torque sensor wire cracking or an optical position sensor getting contaminated, the entire system can lose calibration. When that happens, the control module usually disables power assist entirely as a safety measure, which leaves you with heavy, unassisted manual steering and a warning light on your dashboard. To be fair, this varies quite a bit by manufacturer and by model. Some EPS units are more repairable than others, and the aftermarket repair industry has gotten a lot better in recent years at rebuilding these assemblies instead of forcing a full replacement. It's always worth getting a second opinion or a second quote before assuming you're stuck buying an entire new rack. But on plenty of vehicles, especially from manufacturers who don't sell individual internal components, a single failed sensor still means replacing the whole assembly. Add in the fact that a new rack often has to be electronically coded to your specific vehicle and its anti-theft system, and that the steering angle sensor needs to be recalibrated with a scan tool afterward, because it feeds data to your car's stability control and lane keeping systems. And you can understand why total repair bills in the range of $1,500 to several $1,000s aren't unusual on certain vehicles. There's another long-term risk that doesn't get talked about nearly as much, and it has to do with where these components physically live on your car. Steering racks sit at the lowest point of the front subframe, which means they're constantly exposed to road salt, slush, high-pressure water spray, and heat cycling from nearby exhaust components. A hydraulic rack is essentially bathed internally in oil, which offers some natural protection against corrosion. An EPS rack has sensitive electrical connectors and circuit boards sitting in that exact same exposed environment. Over years of driving through winter conditions, road salt and moisture can work their way past weather seals and start corroding connectors, or even reaching the electric motor itself. This doesn't mean every EPS car is destined to fail. Plenty of them go their entire service life without a single issue. But it is a known weak point, and it's worth being aware of, especially if you're shopping for a used vehicle that spent its life in a colder, salt-heavy climate. Symptoms to watch for include notchy or grinding sensations when turning, intermittent power steering warning lights, or moments where the assist seems to cut out and come back unexpectedly. There's actually one more factor putting strain on these systems that's worth mentioning. EPS motors can draw a significant amount of electrical current, especially during low-speed maneuvers like parking, when steering resistance is at its highest. That places real demand on your vehicle's charging system, which is part of why modern cars increasingly rely on heavier-duty alternators and higher-capacity batteries just to keep voltage stable under that load. Looking at where the industry is heading next, some manufacturers are already moving toward what's called steer-by-wire technology, which removes the mechanical steering column entirely and replaces it with electronic sensors and actuators. In that kind of system, there's no physical connection at all between your hands and the front wheels. Every bit of steering feel you experience is entirely simulated by a motor under the dashboard. It's a natural extension of the direction the industry has been heading in for years, even if it feels like a bigger leap. So where does that leave you as a driver or as someone shopping for a car? None of this makes electric power steering a bad system overall. It's genuinely more fuel efficient, and it's what makes features like lane keeping assistance and automated emergency steering possible in the first place. Those are real safety benefits that hydraulic systems simply can't offer, but it is a trade-off, and it's one worth understanding clearly. You're generally getting less raw mechanical feel, less straightforward and modular repairability, and depending on the specific car and how it's been maintained, potentially a much larger bill if something eventually fails. If you're in the market for a used car equipped with electric power steering, the single most useful thing you can do is ask for a pre-purchase inspection that specifically checks the steering system, rather than relying on a general once-over. Ask about any past fault codes related to the steering module. Check for signs of corrosion near the rack if it's accessible, and take the car on a test drive specifically paying attention to any notchiness, grinding, or inconsistency in steering effort at low speed. It's also worth pointing out that this shift didn't happen overnight, and it didn't happen the same way across every manufacturer at the same time. Some brands held onto hydraulic assist on certain platforms well into the 2010s, particularly on larger trucks and performance-oriented models where engineers were more reluctant to give up steering precision. Enthusiast-focused cars in particular became something of a battleground, with some manufacturers marketing the retention of hydraulic steering as a selling point in itself, right up until emissions and efficiency regulations made that increasingly difficult to justify across an entire lineup. If you're someone who genuinely misses that older style of feedback, it's not something you're imagining or exaggerating out of nostalgia. It's a real, measurable difference in how force travels through a mechanical system versus how it's interpreted and recreated by sensors and software. Neither approach is objectively wrong. They're just solving different problems, and it helps to know which one you're actually driving before you decide what to expect from it. Understanding how these systems actually work under the surface lets you see past the simple marketing language of smooth, effortless steering, and helps you make a more informed decision the next time you're behind the wheel or standing in a dealership lot.